We're going to find all the different parts of the polynomial. So the first thing I like to do is I like to also factor both pieces. So this could also be x minus 4 and x plus 3 on the numerator and x minus 2, x plus 2 on the denominator. So now we can start answering questions. Is there a hole in this graph? In this case, there's not a hole in the graph because there's no common factors between the numerator and the denominator, which means I'm going to do the vertical asymptotes next. The vertical asymptotes come from the bottom or the denominator, and it's the remaining factors. So I'm going to set each one of these factors equal to 0 and solve. Therefore, for the first one, x equals 2 and x equals negative 2 will be the vertical asymptotes. And if I was to draw this out at negative 2 and at positive 2 would be two imaginary lines. The next piece is the horizontal asymptotes. And the horizontal asymptotes are y equals, and here's what I do. I go back to the original equation, and if the degrees are the same, which they are, I'm going to put the coefficients over the coefficient. So whatever the coefficients are, I'm going to put that. So in this case, your answer is going to be y equals 1. Let me give you another example. If I had x squared over x, so that's x to the first. The degrees are not the same, so what I would do here is put a 0x squared, so now the degrees are the same. So in this case, it would be y equals 1 over 0, which is undefined and can't happen. So then we'd have a slant. So in this case, we would move on to a slant. Is there anything else we have to find? So let's say at y equals 1, there's a horizontal. Sometimes we are asked to find the x-intercepts, and the x-intercepts come from the top. So what I'm going to do here is I'm going to take the factors of the top and set them equal to 0. Therefore, x equals 4 and x equals negative 3. So at 4 comma 0 and at negative 3 comma 0, I would have x-intercepts. And then the last piece we can find here is the y-intercept. And the y-intercept, I'm running out of room, so I'm going to put it right here. Y-intercept, I'm going to plug in a 0 for x and solve for y. So the y-intercept, I like to go back to this equation. Well, if all of the x's are 0, I have negative 12 over negative 4, which 3 would be the y-intercept. So if I had to graph this, I would know that this would come here, this would come here. The middle piece, I would have to use my calculator to find out what's going to happen in the middle piece. Somehow it's going to go through this point, but I don't know if it's going to be just something that looks like this or if it's going to squiggly through.